Hello learners, welcome to SWAM online lecture series on the topic Database Management System. I am Professor Madla Bukhari, working as a professor in the Department of Computer Science, Aligarh Muslim University, Aligarh. I am pleased to have you join me today as we explore the fascinating realm of database and database management system. Today we'll discuss about the decomposition and concurrency control. So get ready to understand the crucial topics to enhance your skill with me. In the previous lecture, I have discussed about the dependency preserving decompositions. When you are decomposing a relation, that decomposition must be lossless and FD preserving. It means attributes, we are not losing any attributes. Then functional dependencies. So before going to discuss today's agenda, I would like to answer the previous questions which I had given you in the next lecture. Which I have given you in the previous lecture. The first question is to explain transitive functional dependencies. In database management system, transitive functional dependencies occurs when an attribute's value determines another attribute's and in turn that second attribute determines a third. If attributes A uniquely influence attributes B and B uniquely influence attribute C, then are transitively influence C. Identifying and addressing such dependencies is crucial in normalization, optimizing database structure for efficiency, integrity, and prevention of data anomalies. The next question was, what do you mean by dependency preserving decomposition, and explain in details? The answer is dependencies preserving decomposition is a process in database normalization where a relation is broken down into a smaller one, ensuring that functional dependencies present in the original relation are maintained in decomposed relations. This method safeguards the logical connections between attributes, preventing the loss of dependencies information during the decomposition process and thereby preserving the relational integrity of the data. The next question, describe multi-value dependencies. Multi-value dependency in a relational database occurs when the presence of certain values in one of attributes uniquely determines values in another set independent of remaining attributes. If two sets of attributes A and B are multi-value dependent, changes in A can affect B and vice versa. Recognizing the addressing multi-value dependencies is crucial for normalization, enhancing data consistency, and avoiding redundancy in database design. What are the advantages of dependencies preserving decompositions? The answer is dependency preserving decomposition in database normalization offers several advantages. Firstly, it ensures that the functional dependencies present in the original relation are maintained in the decomposed relations, preserving the logical relationship between attributes. This process helps prevent information loss during decomposition, ensuring that the decomposition relation accurately represent the dependencies of the original relation. Additionally, dependencies preserving aids in maintaining the data consistency minimizing redundancy, and promoting efficient database operation, contributing to the overall robustness and integrity of a relational database schema. So we'll discuss the today's agenda is to discuss example on decompositions, concurrent executions, steps of concurrent execution, and example on concurrency control. Steps of concurrency control. So let's start one by one. So example on decomposition. Till now, I have already explained we have to check a relation is normalized or not. If relation is not normalized, then we have to decompose the relation. That decomposition must be lossy or lossless. So it is very difficult to check. So there are some steps, mathematical here there are mathematical steps. You have to check. If it will follow all three conditions, then we can say this decomposition is lossless. Otherwise, we can say that this decomposition is lossy. So here I am taking one example. Consider a schema R which contains attributes X, Y, Z, W, and the functional dependencies X determines Y and Z determines W. Then the decomposition of relation R into R1 XY and the relation R2 ZY. For that you have to, for lossless joint decomposition, condition must hold. So you have to have three conditions generally. If you have checked, if it will, all conditions must satisfy, otherwise it will, we can say lossy. Attributes R1 intersection attributes R2 must be equal to the R, or you can say attributes R, which satisfy the first condition of lossless joint decomposition. Hence we check the next condition. In the next condition, if attributes R1 must be intersection of attributes R2 is equal to null, it means there is no common attributes in the relation R1 and R2 which violates the condition of lossless joint decomposition. Hence the decomposition is not lossless. Here I am taking example R, X, Y, Z, X, Y, and the other is Z, W. The first condition R1 and R2, we are able to get the all. So we can say the first condition satisfied. The second condition is R1 intersection R2 not null. If it is not null, then we can say that this is a good. If it is null, then we can say this is lossy. Here, so we are not able to find, because here the attributes is X, R1 contains the attributes XY, R2 contains WZ, and here we cannot find. So there is no common for that. That's why it is lossless. By taking next example, I hope it will be more clear. Consider relation schema R X, Y, Z, WP is decomposed into R1 X, Y, Z, R2 Z, W, P, determining whether the above relation R1 R2 is lossy or lossless. So here I am given tables. We contains table 1, 1, 2, 3, 1, 2, 1, 3, and Y attributes contain 2, 4, 4, Z contain A, B, C, A, W attributes contain A, 1, K, P attributes contain W, X, P. For this relation to be lossless decomposition, R should satisfy the following three conditions you have checked. Attributes R1 intersection R2 must be equal to R. Attributes R1 intersection attributes R2 not null, and attributes R1 and intersection of attribute R2 must determine attributes R1, or attributes R1 intersection R2 must determine attributes R2. If there are three conditions, you have to check. If it is fulfilled, then we can say lossy. So here first condition, certify as attributes R1 intersection R2 is the attributes R, X, Y, Z, W, P. We are able to, because there one condition is the ZWP, here is that, and XWP, we are able to combine for that. Certify second condition, R1 intersection R2 not null, it means the Z. Third, not certify are common attributes. Z is not key in any relation R1, R2. Then we can check from the table. Z is repeating here. Z is repeating A 2 times. So hence the relation itna is decomposed into R1, R2 is lossy decomposition. So Z is not the key, because Z has a more than 2 value same. And third example, consider relation schema R X, Y, Z, W, P is decomposed into R1, X, Y, Z and R2, W, P. Determine whether R1 and R2 are lossless or lossy. So on the screen you can see the table X, Y, Z, W, P. For relation R to be lossless decomposition, R should satisfy the following three conditions. Attributes R1 union attributes R2 must be attributes R2. Attributes R1 intersection attributes R2 must not equal to phi, and attributes R1 intersection attributes R2 must determine attributes R1, or attributes R1 intersection attributes R2 must determine attributes R2. So condition first, certify the attributes R1, R2 is attributes R, X, Y, Z, W, P. Then condition 2, not certified as R1 and intersection R2 is equal to phi. So no need to check the third condition. So we can say that since the second condition is not certified, so we will not check the third condition. Hence the relation R, XW, XYZ, WP decomposed into relation R1 and R2 is lossy decomposition. I hope you will understand clearly. You have to check for lossy, because if you have large database, at that time decomposition lossless, at the time insertion, deletion, updation, 3 only you have checked, it is very difficult. So here is the mathematical conditions. So if you will check the, if attributes of R1 and decomposed relation R2 must contain all the attributes, and then the intersection must not equal to phi, and then the key must be. So here there are three conditions, attributes of R1 and R2 must determine R1, or must determine to R2 also. So here, so I will take a next example. Consider relation R X, Y, Z, WP is decomposed into X, Y, Z, W and WP, determining whether the relation R1, R2 are lossless or lossy. So you have to check. In the table, you can see on the screen X, Y, Z, WP. Same example I have used. 1, 2, 3 like that. So here we'll check a relation R to be lossless decomposition. R should satisfy all three conditions as we have discussed in the previous. Attributes R1 union of attributes R2 must be attributes R. Attributes R1 intersection attribute R2 must not phi, and attributes R1 intersection attributes R2 determine attributes R1, or attributes R1 intersection R2 determines attributes R2. So first, check the first condition. Certified by the attributes R1 and R2, you will get X, Y, Z, WP. Certify the attributes R1 intersection R2 is not phi, it means the W is a common. Then certify as a common attributes W key, we can check from the table of the value of W is unique. So here in the table you can say W I J K 1 Z. So it is a unique. Hence we can say that the decomposition R1 and R2 is lossless decompositions. In the last example for decomposition I have taken, and it will be very clear, I hope. Consider relation schema R X, Y, Z, WP is decomposed into relation R contain the attributes X, Y, Z, W and R2 X, Z, WP, determining whether the above relation R1 and R2 are lossless or this one. You can see on the screen in the table R contain the attributes X, Y, Z, P, WP and the values for that. There are 1, 2, 3, 4 tuples. Then check the relation R to be lossless decomposition. So what you'll do, you have to, R should satisfy all the three conditions. First condition, attributes R1 intersection R2 must be equal to attributes of R1, R. Then intersection of R1 and R2 must not phi, and the attributes of R1 and attributes of R1, we take the intersection that determine for functional dependencies must determines attributes R1 or R2. So first condition, certify the attributes R1 intersection R2 is attributes R, X, Y, Z, P. The second condition, certify all attributes of R1 intersection R2 not phi, it means X, Y, X, Z, W. Condition third is certified as a common attributes X, Z, W is the key. We can check from the values of the W is unique, and any combination of W will also be a unique. Hence the relation R contain the attribute X, Y, Z, WP decomposed into R1 and R2 is lossless decompositions. In this way, by giving different example, we are able to find the decomposed relation is lossless or lossy. Multiple users can access and use the same data at one time, which is known as concurrent execution of a database. It means that the same data is executed simultaneously on a multi-user system by different users. While working on a database transaction, there occurs a requirement of using a database by multiple users for performing different operations, and in that case, concurrent execution of a database is performed. So, the step for concurrent execution in database management system, there is a transaction submission, transaction scheduling, concurrency control, resource allocation, transaction execution, transaction completion, transaction recovery. So, we will discuss one by one. Transaction submission means transactions are submitted to database management system for execution. Each transaction consists of one or more database operations such as read, write, or update. The next is transaction scheduling. In database management system, scheduler determines in order. Database management scheduler determines the order in which transaction will be executed based on the factors like transaction priority, resource availability, and concurrence control mechanics. The next is concurrency control. It ensures data consistency and isolation. Concurrency control mechanisms like locking, time-stepped ordering, or optimistic concurrency control are implied. Resource allocation. The database management system allocates necessary resources such as CPU, memory, and disk input-output to each transaction based on its requirements and system availability. Resource orientation. Resource contention may occur if multiple transactions complete for the same resource simultaneously. Next is transaction execution and transaction completions. On the completion of their operation, transaction commit or abort based on their success or failure. There are two: transaction execution and then transaction completion. Then transaction recovery. In the event of a system failure or error, database management system perform transaction recovery to restore database to a consistent state. Consider a simple example with a table representing a bank account and transaction. We will go through the steps of concurrent execution using this example. So here the table, you can see on the table the account number ID, account name, and the balance. The account ID is 101, 102, 103. Account name is Alice, Bob, Charlie. The balance is 1000, 1500, and 800. First step, transaction submission. Two transactions are submitted to DBMS. Transaction 1 and transaction 2. Transaction 1 is Alice transferred $2,000 to Bob. And the second transaction, Charlie deposit 3,000 into his account. Step 2, transaction scheduling. DBMS scheduler determines the order of execution based on the transaction priorities and resource availability. The next third step, concurrency control. In concurrency control, mechanisms are applied to ensure the data consistency and isolation. For simplicity, let's use locking. If one transaction will be executed, then after next will be a start. Transaction 1 locks Alice account to prevent other transaction from accessing it during the transfer. Transaction 2 locks Charlie's account during the deposit operations. Fourth step, resource allocation. Database management system allocates resources such as CPU, memory, and input-output disk based on transaction requirement. The resource allocation will be allocated by database management system. Fifth is the transaction execution. Transaction execute their operation concurrently. Transaction 1 deduct $200 from the Alice account and add $200 to Bob account. Transaction 2 add 3,000 to Charlie account. See updated bank table here, you can see the balance will be changed and it will 800, 1700 and 1100. Sixth step, transaction completion. Transaction 1 commits successfully and the change to Alice and Bob's accounts are persisted. Transaction 2 commits successfully and the change to Charlie's account persisted. Transaction 7, transaction recovery. In the event of system failure, transaction recovery mechanism ensure database consistency by rolling back incomplete transaction and redoing committed transaction. We take the next example. Consider another example with table representing a library's books, inventory, and borrowing transactions. We will follow the steps of concurrent execution using this example. So you can see on the screen, original table, library inventory, books ID, title, author, available copies, book ID 101, 102, 103, the book title 1984, author George Orwell, and so on. Available copies of 532. So here you have to check the first step, transaction submission. The two transactions are submitted to database management system. Transaction 1, John borrows a book of 1984. Mary borrows a book of To Kill a Mockingbird. Transaction 2, scheduling. So the second step, transaction scheduling. There in the first step we have decided that there are how many transactions. There are two transactions. John borrow a book and Mary borrows a copy. Then the second step, transaction scheduling, database management system scheduler determines the order of execution based on the transaction priority and resource availability. Third step, concurrency control. It means for that the locking are used. Transaction 1 lock the 1984 book record to prevent the other transaction from borrowing the same copy simultaneously. Transaction 2 locks the To Kill a Mockingbird's book record for the same purpose. Step 4, then after resource allocation, you have to resource allocation. DBMS allocates resources based on transaction requirements. Step 5, transaction execution. Transaction execution execute their operation concurrently. The first transaction determines the available copies of 1984 by 1. Then transaction 2 decrement the available copy of To Kill a Mockingbird by 1. It means transaction 1 and transaction 2 decrement 1 value from the copies of 1984, and also transaction 2 decrement the available copy of To Kill a Mockingbird by 1. You can see on the screen after that transaction. Then you can see on the screen here is the book ID 101 1984. The copy will become 4. That 2 it will become 2 and pride. So in the previously here the 5 3 2 after transactions you can see on this screen it will become 5 become 4, 3 will become 2, and the second 6th step, transaction completion. Transaction 1 and transaction 2 commit successfully and the changes to available copies are persisted. The 7th step, transaction recovery. In the case of system failure, transaction recovery mechanism ensure database consistency by rolling back incomplete transactions and redoing committed transactions. A step of database management system concurrency controls. Here also transaction identifications, transaction serializations, concurrency control mechanism, and log acquisitions. In transaction identifications, database management identifies incoming transactions and assign unique transaction identifier to each transactions. Next is transaction serialization. Transactions are serialized to determine their execution order. This can be based on the factor like transaction timestamps or predefined priorities. Then after concurrency control mechanism selections, then the lock acquisitions. If locking is used, if locking is used, transactions acquire locks on the data item by intended to read from or write to. Locks prevent other transactions from accessing the same data concurrently, ensuring data consistency. Then transaction execution. then it will come to a conflict resolution also is there. Then the last is deadlock detection and resolution and transaction commitment and logging and recovery. So transaction executes their operations sequentially or concurrently depending on the selected concurrency control mechanism and availability of the resources. Conflict resolution: if two transactions attempt to access the same data item concurrently and one or both transactions hold conflict locks, the database management system resolves the conflict according to predefined rules. Then deadlock detection and resolution. Database management system monitor for deadlock situations where transactions are waiting indefinitely for resources held by each other. If deadlock is detected, the database management system resolves it by aborting one or more transactions involved in the deadlocks. And the next step is the transaction commitment. And next is logging and recovery. Same way we take an example. I hope you have to check step by step. So consider a simple example with a table representing a bank account and transaction. We will go through the steps of concurrency control using this example. So here you can see on the screen account ID, account name, and the balance is 101, account ID 102. The bank account detail, it contains three attributes: account ID, account name, and balance. Then you have to check transaction identifications. Two transactions are submitted to the database management system. Transaction 1, Alice transferred 200 to Bob and Charlie deposited 300 into his account. The step 2, transaction serialization. Database management system serialize the transaction based on the predefined priorities or timestamps. So let's assume transaction 1 has higher priority than transaction 2. Step 3, concurrency control mechanism selection. Let's use locking for concurrency control mechanism. And the step 4, lock acquisition. Transaction 1 acquires lock on Alice and Bob account to prevent other transactions from accessing them during the transfer. And transaction 2 acquires a lock on the Charlie's account during the deposit operations. So when your deposit operation is done, Charlie account will be locked. Step 5, transaction execution. Transactions execution their operations sequentially or concurrently, depending on the selected concurrency control mechanism and resource availability. Transaction execution operation will be selected. 6th step, conflict the resolution. You have to remove the resolution. If transaction 2 attempt to access Charlie's account while transaction 1 hold a lock on it, transaction 2 may wait until transaction 1 release the lock or abort or retry later. What you do? Update table, bank account after transactions. Assuming both transactions were successfully executed, then the Alice balance will be reduced by 200 and Bob balance will be increased by 200 and Charlie's balance is increased by 300. Step 6, conflict resolutions. If transaction 2 attempts to access Charlie's account while transaction 1 hold a lock on it, transaction 2 may wait until transaction 1 release the lock or abort or retry later. And then update the table, bank account after transactions. Assume both transactions were successfully implemented. Then what will do? the Alice balance is reduced by 200, Bob balance is increased by 200, Charlie balance increased by 300. And the seventh step, transaction commit. Seventh step, transaction commitment. Both transaction commit their changes to the database if all operations were successful. If any operation fails or conflict arise during the execution, transaction may be aborted or their change rolled back. So we take the example also. Consider example with a table representing a restaurant's menu and ordering transactions. We will illustrate the steps of concurrency control using this scenario. For that, I have taken an example of a restaurant menu. Item name and price. Item ID 101, 102, 103. Item name is burger, pizza, salad. $10, $12, $8. Then you have to check transaction identification. Two transactions are submitted to database. One is John ordered the burger and Mary ordered the pizza. There are two transactions they have ordered. The transaction serialization, it means database management system serializes the transaction based on the predefined priorities or timestamp. The third step is to concurrency control mechanism selection. Let us timestamp order as the concurrency control mechanism. And the fourth step, lock execution. You have to lock when one transaction is executing. Here, timestamp order does not use lock's ability. So here we have used timestamp ordering. So it will not use lock explicit. Instead, transactions are ordered based on their timestamping. Transactions are ordered based on their timestamps. The fifth step, transaction execution. Transaction executes their operations sequentially or concurrently without acquiring locks. The sixth step is to conflict resolution. After transaction execution, database management system compares transaction timestamps to detect conflicts. If two transactions attempt to order the last available item concurrently, a conflict is detected. It means you have to update the tables. The restaurant menu after transactions, you can see on the screen, I have already written. Assuming both the transactions were successfully executed, then available of a burger is reduced by 1 and availability of pizza will be reduced by 1. 7 transaction commitments. Both transactions commit their changes to the database if all operations were successful. If any operation fails or conflicts arising during the execution, transaction may be aborted or their change rolled back. As we wrapped up today's discussion, I hope that as we read up today's discussion, I hope this lecture which we have discussed have equipped you with valuable insights and practical skills that is applicable to your database management endeavor. Thank you for your active participations. Thank you for your active participation and we eagerly anticipate your presence in our upcoming lectures. Wish you a wonderful day ahead.